Family Guy. Animated series Family Guy is an Adult Swim show that features the adventures of the Griffin family and the silly antics they get themselves into. The Griffin family consists of father, Peter Griffin, mother, Lois Griffin, oldest son, Chris Griffin, the girl one, I forgot her name, the baby of the family, Stewie Griffin, and the family's pet dog, Brian Griffin, that can for some reason speak fluent English. The Griffin family is also accompanied by a variety of side characters and friends who add their own charm to the show. It's a great comedic show and a cult classic in Adult Swim's catalog. Due to its popularity, just about everyone knows Family Guy, its characters, or maybe just a single joke or clip they saw online. It's become an icon in TV history, and today, I'll be using Family Guy for my physics final.
Peter, no! Peter! Peter!
The topic I'll be conveying through Family Guy is the conservation of momentum. But first, we have to cover, what is momentum? Momentum is described as inertia in motion. A lot of momentum is seen as a lot of speed. Momentum is also known as the product of mass times velocity. So if something is in motion, the momentum can be manipulated with two factors, those two factors being mass and velocity. When Peter Griffin tries to run through a wall, just by himself with no advantages, all he does is end up hurting himself and falling to the floor. But when Peter Griffin drives his car and crashes his car into the house, he busts right through the wall, no problem. This is due to his upgrade in both mass and velocity, aka momentum. Now that we understand momentum, let's get back to the actual topic of this video, the conservation of momentum. The law of conservation of momentum states, momentum of the system before collision is equal to the momentum of the system after collision. So to measure conservation of momentum, you have to use this specific formula. M1 times V1 plus M2 times V2 is equal to M1 times V1 plus M2 times V2. The side to the left of the equal sign shows the pre-collision. The mass and velocity of object 1 plus the mass and velocity of object 2. That same rule applies for the side right of the equal sign. The only difference is the right of the equal sign is the after collision. So the mass and velocity of object 1 plus the mass and velocity of object 2 pre-collision should equal the mass and velocity of object 1 plus the mass and velocity of object 2 after collision. Now this complex equation may look like it's pretty hard just because how lengthy it is, but it's actually quite the opposite, pretty simple. It's all just a case of plugging in data from an equation. First, locate your two main objects. Start by finding the mass and velocity of the two objects before they collide. Multiply each object's mass and velocity together so then the equation simplifies to mv1 plus mv2. Do the same thing but for the after collision. If you followed the same steps correctly, you should now have mv1 plus mv2 equals mv1 plus mv2. Past that point, you just have to do basic algebra to solve the equation.
I'm gonna need these by Friday. Ugh, is that gonna give us enough time to cross-check the...
Chicken gave me a bad coupon.
So Peter Griffin stands at a surprising 6'7" and weighs about 270 pounds. Ernie the Giant Chicken, yes, that is his real name, is only an inch shorter at 6'6" with a weight of 266.76 pounds. Peter charges at Ernie at 10 meters per second, which results in the two colliding and crashing through the wall. Peter Griffin must have been training because last time he tried to run through a wall, he knocked himself out. But back to the task at hand. The problem we will be solving based on that clip is what is the velocity of Ernie the Giant Chicken before colliding with Peter? Let's plug in all the information we have. Peter will be object 1, and Ernie will be object 2. Peter's mass is 270 pounds, but when we solve for momentum, we don't use pounds, we use kilograms. So Peter's converted weight would be 122.47 kg. As stated earlier, Peter charges at Ernie at 10 meters per second. Ernie the Giant Chicken weighs 266.76 pounds. Converted to kilograms, Ernie weighs 121.00003 kg. We don't know Ernie's velocity because that's what we're solving for with this equation. So far, we have 122.47 kg times 10 meters per second plus 121.0003 kg times negative v. The reason the v is negative is because, if you notice in the video, Ernie is moving backwards from Peter. So that backwards movement results in the velocity being negative in the equation. For the after collision, the masses are the exact same, but now Peter and Ernie are both crashing to the wall at 10 meters per second. So the final equation should be 122.47 kg times 10 meters per second plus 121.0003 kg times negative v equals 122.47 kg times 10 meters per second plus 121.0003 kg times 10 meters per second. We can actually simplify the after collision because both Peter and Ernie are moving at the exact same speed. So we could simplify the right side of the equation to 122.47 kg times 121.0003 kg, and both of those being times by 10 meters per second. Next step would be multiplying everything we can. This gives us 1,224.7 kg minus 121.0003 kg v equals 2,434.7. Subtract both sides by 1,224.7. We now have negative 121.0003 kg v equals 1,210. Divide both sides by negative 121.0003. Finally, you're left with v equals negative 9.999 continued meters per second. So the pre-collision of Ernie the Giant Chicken was 9.99 meters per second. So yeah, that was conservation of momentum taught by me through Family Guy. I hope you enjoyed, and thank you for watching.
Remember the time, and we know even at my lowest, I'm a family guy.